Hello again, students. Let's do the megapixel punch. Okay, find the missing length and height for each television. The equation's already provided. So, did you know that when they tell you the length of a TV, that's actually the diagonal? So when they say an 88-inch HD TV, that's the diagonal corner to corner. And then same thing with a standard 44-inch, it's the diagonal. So HD TVs have a 16:9 ratio, and then standard definition is a 4:3 ratio. So we're going to use this thing called the Pythagorean theorem. We'll do it a lot more in chapter 10, but it's already set up. So we can actually solve, if we know the diagonal length is 88, so if we know this is 88, and if we know this is 44, we can actually use this thing called the Pythagorean theorem to find these x values here, and then we can actually apply it to find, if we know the ratio, if we know this 9 to 16, 3 to 4 ratio. If we know the ratios, then we can use the Pythagorean theorem to solve for x, and then once we have x, we can find all the values. So it's already set up for us. So we actually need to square these things, all right? So I don't have a lot of room to work. I wish I gave myself more room, but here we go. So we got to take 16 squared. Okay, cool. That's going to make 256x squared. Then we got to do 9x squared. That's going to make 81x squared, excuse me. And then 88 squared is 7,744. So up here, I'm going to solve it up to the side here. So we actually need to combine these x squared values, put them together. When we do that, we get 337x squared, and that's going to equal the 7,744. All right, so now how do we solve for x? Well, we divide both sides by 337. Divided by 337. That's going to cancel. Instead of simplifying that, I'm just going to go ahead and square root both sides. All right, so when you square root all of that noise, you get x to the nearest tenth. You get x equals 4.8. So if you know that x equals 4.8, you would do 16 times 4.8 to get the width. And then you do 16, not 16, you would do 9 times 4.8 to get the height. Do I have those calculated? No, I don't. So sorry. 16 times 4.8 is going to give us a length, TV length of, there's no space here, I'm so sorry, 76.8 inches. And then 9 times 4.8 is going to give us a height of 43.2. Okay, so again, the equation's already set up. You just need to square it, rewrite it, or combine the like terms. You're going to have an x squared and an x squared. Put the x squares together, divide by that number, square root both sides, nearest tenth, 4.8. Once you get 4.8, plug it in times 16, plug it in times 9. There's going to be your length and your width for the HD TV. Now we're going to follow the same process for the standard TV, but the numbers aren't going to be as bad. So 4x squared is going to be a 16x squared. 3x squared is a 9x squared, and 44 squared is 1,936. Combine the like squares, and we're going to have this one to solve. We're going to have 25x squared equals 1,936. So let's divide by the 25, divide by the 25. It's going to cancel, so now we can just square root this side, so square root that side. The square root of all that noise is going to be x equals 8.8. So what you're going to do now is you're going to go length. You're going to go 4 times 8.8. I don't have enough room. The TV's too small. I can't write it on there. And then you go 3 times 8.8. So let's go ahead and see what those values are. 4 times 8.8, 3 times 8.8. My values are, TV length is going to be 35.2 inches, and the TV height is going to be 26.4. All right, so again, a quick replay, simplify the already pre-made equations, combine the x squared values, one step square root, one step square root. Once you have the x values, plug them back into the given ratios, 16x, 9x, and then 4x and 3x for the separate TVs. And there you have your HD TV length and height and your standard TV length and height. All right, cool. See you in class.